morning, everybody. I want to start off by apologizing for the delay in this video. More information will be given during class about the delay, but for right now, let's just jump right into it. Remember that during these presentations, feel free to pause the video to get down the information that is on the screen. Also, when we are practicing some of the problems, if you want to take a moment to pause as well, I'm going to go through this fairly quickly. So here we go. Moles to gram stoichiometry. We've already talked about how we can go from moles of one substance to moles of another. Now we're going to integrate molar mass into this relationship. And so to start off, we are finally actually getting into what's really known as stoichiometry, which is just a long, convoluted scientific word for the study of mass relationships. So how does the mass of one object compare to the mass of another object? And usually it is two objects that are interacting with each other somehow. For chemistry, we're talking typically about a chemical reaction. So the molar mass was really the first type of stoichiometry we looked at, but we didn't call it that at the time. It relates a compound's mass to its molar quantity. So, for example, if we wanted to talk about the molar mass of sodium hydroxide, sodium hydroxide has 40 grams per mole. So the relationship is 40 grams of sodium hydroxide to 1 mole of sodium hydroxide. But like I mentioned earlier, we already know the mole-to-mole ratio, which can be determined from a balanced chemical equation, and how the molar masses can be determined for any given compound. Therefore, when we combine these together, we can use the mole-to-mole ratio to determine the mass of a given substance by incorporating that substance's molar mass. And this is typically much more beneficial and useful for scientists. It can be measured in a lab, it can be tested and then verified using a variety of equipments that measure mass. So let's jump right in. What does a word problem look like with something like this? And hopefully you'll notice that it is very similar to previous problem. So here we go. The Haber process is extremely important to the agricultural industry as it provides a major source of nitrogen for fertilizers and pesticides. The reaction for the Haber process is 3 moles of hydrogen gas reacting with 1 mole of nitrogen gas to produce 2 moles of ammonia gas. How many grams of ammonia can be produced from 18.9 moles of hydrogen and an unlimited supply of nitrogen? So going through here, remember we have a couple different steps that we want to take. First, we want to identify the unknown. So looking here in the equation, the unknown says how many grams of ammonia can be produced. So how many grams of ammonia? We are talking about a certain mass of ammonia. Okay, the second part here says to identify the given. So let's adjust our tool real quick. So it says how many grams of ammonia can be produced from 18.9 moles of hydrogen and an unlimited supply of nitrogen. This unlimited supply of nitrogen is in there just to tell you that the hydrogen is the only thing that is going to affect the amount of ammonia. So our given in this case is going to be 18.9 moles of hydrogen. Okay, so down here there's 2 relationships we need to know. We need to know the mole ratio and the molar mass of ammonia. The mole ratio, I'm going to look up here. Ammonia is over here, so 2 moles of ammonia is related to our given, which is hydrogen. So up here, 3 moles of hydrogen. And then because we're looking for the mass or the grams of ammonia, I also included the molar mass of ammonia in here as well, because this tells us the relationship between moles of ammonia and grams of ammonia. Okay, so in here we have all the information now that we need. Here is our little grid to help us out. Remember, we start with the given, and then we incorporate the mole ratio, but now we're going to incorporate a second portion. We are going to integrate the molar mass of our unknown as well. Okay, so starting off here with our given, we have 18.9 moles of hydrogen. Our mole ratio here, because I have moles of hydrogen here in my given, I want moles of hydrogen on the bottom. So looking at the mole ratio, that's 3 moles of hydrogen. And I am converting to ammonia, so 2 moles of ammonia on the top. So the moles of hydrogen cancel, and then now we're left with moles of ammonia. Now to convert from moles of ammonia to mass of ammonia, we need the molar mass right up here. And from that, 1 mole of ammonia goes on the bottom because I want moles of ammonia to cancel. And then we get 17.031 grams of ammonia. Okay, now when you go through to put this in your calculator, 18.9 times 2, then you're going to divide by 3, and then you're going to multiply by 17.031. Your calculator is going to give you a long number, so 214.59 grams of ammonia, but we know that that's not completely accurate. We need to round this to 3 significant figures, so your complete answer is 215 grams of ammonia. Okay, final answer, 215 grams of ammonia. Now, for those of you who need kind of the actual individual steps for our concrete sequential learners, step number 1, convert the given moles to the unknown moles using the mole ratio. And then step 2, convert the unknown moles to the unknown mass using the unknown's molar mass. Okay? So let's take a look at another problem. Again, in this section, you want to copy the problem down, try it on your own, pause it while you're doing that, and then press play to double check. So in this one here, it says ethanol can be created from a special double displacement reaction as illustrated by the reaction. 2C2H5Cl plus calcium hydroxide to yield, add in my arrow there, to yield 2C2H5OH, which is ethanol, and 1 mole of calcium chloride. So the question says, how many grams of calcium hydroxide are needed to completely react with 4.6 moles of C2H5Cl? So our unknown is how many grams of calcium hydroxide, and our known is 4.6 moles of C2H5Cl. So jotting this information down, we want mass of calcium hydroxide, are given 4.60 moles of C2H5Cl. We're looking for the relationship between our unknown and our known. So our unknown is calcium hydroxide, so 1 mole of calcium hydroxide is related to, our given is C2H5Cl, so 2 moles C2H5Cl. And just to emphasize here, the 2 moles came from the coefficient here, and the 1 mole came from the coefficient here. Okay, mole ratio. Here we have the molar mass of calcium hydroxide. So Going through to solve, starting with our given 4.60 moles of C2H5Cl. Going to the mole-to-mole ratio, 2 moles of C2H5Cl, 1 mole calcium hydroxide, and then going to our mole ratio, 1 mole calcium hydroxide is 74.093 grams calcium hydroxide. And then just to double check, moles of C2H5Cl, moles of C2H5Cl, those cancel. Moles of calcium hydroxide, they cancel. And so 4.60 times 1 divided by 2 times 74.093. Again, your calculator is going to give you a long number, 170.4139 grams calcium hydroxide, but three significant figures, so 170 grams of calcium hydroxide. Okay? Alright, for the last problem, I want you to do it completely on your own. There is no guide or anything here, so take a moment, pause this, because the answer is going to get revealed here in just a second. It says how many grams of calcium chloride are created when 4.60 moles of C2H5Cl react using the above equation. Going through, ultimately, you'll end up with 255 grams of calcium chloride. All right, hopefully you got that answer. Hopefully the notes went by fairly quickly. I apologize again for the length of the video and for the delay in getting it to you.